Hello guys, welcome to another section of Math. Today in this video we'll be looking at how to show that this definite integral here is equal to pi. As the question states, show that this definite integral which goes from -1 to +1 is equal to pi. So without wasting much time, let's get started. All right, let's bring this one down here. Okay, so integral which goes from -1 to 1 square root of 1 plus x divided by square root of 1 minus x dx. Here, what we are going to do here is what? We are going to rationalize the denominator. We are going to rationalize the denominator. Maybe u sub can work here for you. Maybe partial fraction can work here directly for you, or maybe integration apart can work here directly for you. But first, in this video, we are going to first rationalize the denominator before we choose approach that we are going to use. Okay, so let's rationalize it. So okay, let's rationalize, and I believe you know how to rationalize what? A fraction which contains what? Said in the denominator's position. That is, we are going to multiply both the numerator and denominator by what? Square root of 1 minus what? X. Okay. Alright. Now when you multiply this by this, now from the multiplication law of said, square root of a times square root of b is equal to square root of a times b. So this one times this one will give us square root of 1 plus x times 1 minus what? X. Okay, now when we come here, square root of 1 minus x times square root of 1 minus x will give us what? Square root of 1 minus x all squared. Alright, so here when you open the bracket, we are going to get this time this one will give us 1, this time this one give us minus x, this time this one give us positive x, and then this time this one give us minus x squared. So we are going to get, when you open the bracket, you are going to get 1 minus x plus x minus x squared. So you could see minus x and plus x will go away until we left with 1 minus x squared. Now when you come here, these two will take away the square root sign, okay, and to be left with 1 minus what? X. Alright, after rationalizing, there is what you have gotten: square root of 1 minus x squared divided by 1 minus what? X. What are you going to do here? Well, I don't know, maybe u sub can work for you here also. Partial fraction or maybe integration apart can also work here for you. I'm not saying it won't work, it will work, but here you're going to apply trig substitution to solve this problem. You're going to apply trig substitution to solve what? This problem. Okay, so let's draw a trig substitution. Before you can use the substitution, you first have to draw what? Your right angle triangle. Okay, just to help you know what are you going to put or replace what? X. Okay, so let's draw a right angle triangle. So trig substitution. Now let's draw a right angle triangle. Okay, My right angle triangle doesn't have the symbol, but still you can confirm it's a right angle triangle, right? Or isn't it? Yeah, it is. If it's not, we are taking it as that. Oh, just by the way. Let's continue. Now, remember the other time I told you that when you draw your right angle triangle, the position of the angle, not the 90 degrees angle, but the position of the angle, either beta or let's say any variable that used to represent the angle, or maybe theta, determines or shows or depicts the names of what? This side and this side, but not this side. The name of this side and then this side depends on the position of what? The angle. So if the angle is here, this side is what? Our opposite, because that is the line facing what? The angle. And then this side becomes our adjacent, because that is the line on which the angle is what? Resting on, or which is adjoining to what? The angle. If the angle comes here, it becomes vice versa. That is, here becomes our opposite, and then here becomes our what? Adjacent. And this side, this line which is facing the 90 degrees angle is what? Our hypotenuse. Okay. So here we are going to position our angle theta here. Let's position it. All right. Now we are going to write x1 and the square root of 1 minus x on the sides of what? This triangle. That is here, here, and here. We're going to write it on this, on the sides of what? This right angle triangle here, by applying the Pythagoras theorem or law. Here, assume here is A, and then here is B, and then here is C. C squared is equal to A squared plus what? B squared. That is what the Pythagoras, what the Pythagoras theorem would state. Now, what if we want to find this side, provided this side and this side has been given? That is going to be, this side will be equal to square root of C squared minus what? A squared. So if here is if here is B, we are gonna get B squared is equal to C squared minus what? A squared. Then we take square root of both sides, and we get B is equal to square root of what? C squared minus what? A squared. So applying this preamble here, we are going to write 1 and then s and the square root of 1 minus s squared what? On the sides of the triangle. But you see, we are subtracting x from what? 1. Okay, so that means the 1 has to be on what? Our hypotenuse position. So we are going to write our 1 here, and then we are subtracting x from it. Then we position our x on this side. So this is our x, and as usual, how are we going to get this side? Assuming if it is still b, that is going to be the square root of this squared minus this squared. Okay, so here is going to be square root of 1 minus x squared. Good. Now we have written on it very successfully. So now we are going to generate our ratios from the triangles together with the numbers written on it, but we form the ratios by using their what? Formulas. So when we choose, let's say cosine will give us what? Adjacent over hypotenuse. That is this side over this side. But to differentiate, we'll take a little bit time. Sine will give us what? X over 1. That is sine theta will be equal to what? X. And that one is more easy to differentiate as compared to cosine, and what? Tangent. Tangent will give us this over this. Differentiating will take a lot of time, right? So let's choose sine. So sine theta is equal to this one over what? This. So sine theta is equal to what? X. Good. Now let's differentiate. when you differentiate, you're gonna get cos theta, the theta is equal to dx. Now mind you, remember in my previous video I said that you can also generate another ratios from the Pythagoras theorem principle, from Pythagoras theorem principles, or from the right angle triangle as illustrated here, to replace maybe a whole question that you are integrating in the integrals. What I mean is, we are integrating square root of 1 minus x squared all over 1 minus x. What I mean is, if we don't want to substitute this one into what, maybe either the square root or maybe the 1 minus x, we can generate another ratios from here that can be equal to one of them, either the numerator or the denominator. My previous video I said that, but I didn't what use it. We didn't go by that approach. Okay, we just substituted this one into the square root, and then we got the ratio that ratio is supposed to be what there. Okay, but here I'm not going to substitute this one into the square root in the integral, but rather I'm going to find a ratio that can be equated to that square root of 1 minus what x squared, or 1 minus what x, either the numerator or the denominator. Now let's check. When we choose tan will give us this over this. Even x tan theta will be equal to this. That won't work. But what about, we have already choose sine, so sine is not included. Sine is what? Excluded, sorry. What about cosine? Cosine will give us what? Adjacent over hypotenuse. The adjacent is what? Square root of 1 minus x squared. And the hypotenuse is 1. So cos theta will be equal to square root of 1 minus x squared over 1. And that one will give us cos theta is equal to what? Square root of 1 minus what? X squared. So you see, we can replace square root of 1 minus x squared with cos theta without substituting this one into the square root. Okay, so that is what we are going to do here. So cos theta is equal to 1 minus x squared. Now we are gradually moving from the x world into the u world, but to completely enter that particular world, the limit also has to be in the u world. But how are we going to know the value? The numbers there are values in the x world, but what will be the values for those numbers in the theta world? Well, to do that, we know that sine theta is equal to x, right? So we just make theta the subject. So we just take sine inverse of both sides, and theta will be equal to sine inverse of what? X. So to find the value of 1 and the minus 1 in the theta world, you're going to replace them into the whole sine inverse. Okay, so theta will be equal to sine inverse of 1. Sine inverse of 1 will give us what? It will give us 90 degrees or pi over 2. You can choose to maintain the 90 degrees or write what? Pi over 2. Now, this and this, they are the same, but this one is what? Degrees, and this one is what? Radian. But normally, in theta world, what we normally do is that when we get the degrees, we convert or change it to what? Radian. That is why I did it this way, either this or that. When you do it this way, you are not wrong. But normally, generally, we convert it to what? A radian, and the radian of 90 degrees is what? Pi over 2. Now, the positive one gave us what? This. What about minus 1? Minus 1 just give us the same thing. Just give us the same thing of what? This, but what? Negative. It's a matter of just getting this and then that. Okay. So when you put minus 1 here, you're gonna get theta is equal to minus 90 degrees or minus pi over 2. Okay. So when we draw our integral sign, instead of putting minus 1 and then 1 there, we are going to put either 90 degrees or minus 90 degrees, or pi over 2 and then minus pi over 2. Okay, so Now that we have completely entered the theta word, let's write our integral. Good, this one is representing what, dx, and then this one is representing what, square root of, is here, square root of x minus what, square root of 1 minus what, x squared. Okay, and then the theta here is representing what, dx. Now you can see we are in what, the theta word, and you can confirm all the workings here are in what, the theta word. Okay, so let's continue. Now this times this one will give us what, cos theta squared divided by 1 minus what, sine theta, the theta. Good. Now cos theta squared divided by 1 minus sine theta, the theta. Now when we look at cos theta squared, can you make substitution from here? Maybe u is equal to this, then you differentiate. When you differentiate, still some of the theta will be what, left. And what we're going to replace that unless we find take inverse of something. So what are we going to do? Well, we know that cos theta plus sine theta is equal to what, 1. So if we are having cos theta, it's a matter of making what, cos theta the subject from this equation. You know that cos theta or cos x squared plus sine x squared is equal to 1. So if we make 1 the subject, maybe cos theta is cos x squared the subject, you're gonna get cos x squared is equal to 1 minus what, sine x squared. The same thing is applied here. This one is equal to 1 minus sine theta squared. Okay, so you're going to replace this one with 1 minus sine theta squared. Good. Well, we are doing good. Yeah. 1 minus sine theta squared divided by 1 minus sine theta. What are you going to do? Ideally, what are you going to do? It's just a matter of cancel this one with this, and it will be left with 1 minus sine theta, and then we are good to go, right? Well, if you do it like that, you are wrong. The power of this one is 1. The power of this one is also 1. Here the power is 2, but here is 1, but it can still be what, 2, because when you square it will give you what, 1. Here it can be 2 because when you square it will give you 1, but this side cannot be 2 because we didn't get that from the beginning. That's what you have gotten. So how can we make this one 2 so that both top and down will cancel out? That will not be possible. So what are you going to do? Any idea? Then we are stuck. You won't be able to give a proof. You won't be able to solve our problem. Then let's end it. Well, the idea here is that 1 minus sine theta squared here, this one here can be written as 1 squared, and when we do that, it becomes a difference of 2 squared. So this one actually can be factorized by applying the idea of difference of 2 squared. This one here can be written as what, 1 squared, and when you do that, it becomes 1 squared minus sine theta squared. Okay, so the moment it becomes like that, we can apply difference of 2 squares, then we factorize. So when you factorize 1 squared minus sine theta squared, you're gonna get 1 plus sine theta multiplied by 1 minus sine theta. When you expand these two brackets, you're gonna get this one back at the end of the day. So here you're gonna factorize this one, and when you factorize this, you're gonna get 1 plus sine theta and then 1 minus sine theta, the theta. Okay, good. By factorizing, we have gotten to know that by factorizing, we have gotten some of them, which can be what eliminated by what cancellation. Okay, 1 plus sine theta multiplied by 1 minus sine theta divided by 1 minus sine theta. This and this are the same, so this one will just cancel out with this one, and to be left with what 1 plus sine theta. Okay, so this one will give us what 1 plus sine theta. All right, integral which goes from minus pi over 2 to pi over 2 plus pi over 2, that is 1 plus sine theta d theta. Now this one is very simple to integrate. This one we cannot do anything again. The only thing that we can do in the next step is to either differentiate or write our answers for each of them directly. But here we're not going to split them because we easily know the answer to this one and also what this one. And I believe why you know that integral of maybe sine is equal to minus what cosine. When you integrate, you're gonna get minus cosine. I believe you know the reason why. Don't worry, I've also given a proof of that, and I'll try and leave in the description section below so that you can go click on it, watch how, and then know the reason. Watch how and then know the reason. Okay, so now let's integrate. Now when you integrate this one, you're gonna get theta, and then when you integrate this one, you're gonna get minus cosine, minus cos theta, minus cos theta, minus cos theta. So you're gonna get theta minus cos theta. I should have bring maybe two verticals here, one here, and then one here, and then I'll put these two limits, one as subscript and the other one as for superscript. But well, I didn't do that. You don't worry. I'm gonna do that one when we substitute the values of theta into what this expression. Okay, so the answer to the integral question that we are working on is what theta minus what cos theta in the theta world. But don't worry, when we are done with this, we are done in the theta world, I will also take my time and then take this answer back to the x word and show you how the calculation in the x word is also what done. Okay, so now that we know our answer to the question or the integral problem, we will not bring our plus c because it is what a definite integral. So we have to find what a value because the limit has been what given. So we cannot bring our plus c or end here. So we are going to substitute those values into this expression. Then we know the actual value that our question is what looking for. Actually, we said it is equal to pi. So we are going to substitute this one into this to find out if actually it will be equal to pi. Okay, so let's substitute them into the expression, which is theta minus cos what theta. This one is representing what theta, the values of what theta. So theta is what pi over 2. With this one, though I said I should have bring that one, we always take the upper one minus what the lower one. That is the upper bound minus the lower bound, or the upper limit minus what the lower limit. And the upper one is what pi over 2. So when you put pi over, you put that one into the whole whatever you had. Make sure it's not an equation, it's an expression. So we put it into the whole of this, and there is what we have gotten. And then minus, ideally we subtract, okay, but the next limit here is negative, so we're just going to put this one also here. And when you do that, that's what you are going to get at the end of the day. Okay, all right, so pi minus cos pi over 2. We from the previous work we saw that pi over 2 is same as 90 degrees. So cos 90 is what? 0. Cos 90 is what? 0. The same thing, cos pi over 2 is what? 0. You can use your calculus. Make sure you change the degrees to radian, and then you punch it on your calculus. You see that it will give you cos pi over 2 is what? 0. So here will be 0, Now when you come here, you're gonna get minus pi over 2 minus this one 2, you're gonna get what? 0. Either minus 0 is neutral, whether positive or negative, you're just gonna get what? 0. And when you get 0, to be left with this one and then this. So here you're going to be pi. Sorry, let's open the bracket. Minus times this one give us what? Plus. So that is going to be pi over 2 plus pi over 2. Hey, it seems we are doing something good. It seems we did not waste our time. So pi over 2 plus pi over 2. This one is same as what? Half plus half. And half plus half will give us what? That is 1. So pi over 2 plus pi over 2 give us what? 2 pi over 2. 2 pi over 2. And 2 will cancel out with 2 and to be left with what? Pi over 2. So pi over 2 plus pi over 2 is equal to what? Pi. Whoa. That is really cool. We didn't waste our time. We have managed to give what the proof or to work to confirm to what the question is what saying. Okay, so the calculation in the U word has proved that the question is what equal. Actually, that definite integral question is actually equal to what? Pi. What about if here, if you don't want the pi, if you don't want this pi over 2 and the also pi, you can replace it with what? 90 degrees. You know, when you put 90 degrees here and then also put 90 degrees here, you're going to get 180 at the end of the day. You have to convert it to what radian and you're just going to get this one. Okay, but you don't worry, I'll be using that one in the x word. So the calculation in the theta word has proved that the integral is equal to pi. But what about if we had decided to go back to the x word? Let's find out the answer if s word will also prove that the answer is equal to theta. Okay, so with this same expression, we are going to take this one to the x word and then we put our values what into them. Okay, now let's take it back to the s word. This one in the s word will give us what? Let's find out. Or going back to the x word, we know that theta is equal to sine inverse of x and then cos theta is equal to square root of 1 minus x squared. Okay, now that we do these two, let's write our expressions for it. Okay, good. So you're going to be sine inverse of x minus square root of 1 minus x squared. Good. But mind you, here in this x word, we don't need any angle. So we don't need the 90 degrees in order to substitute what it for what the x. We only need the numbers, the figures that were given in the original question, because the original question was in the x word. So that positive 1 and the minus 1 was in the x word, not in the theta or any other word. So if we have returned to x word, all that we have to do is that we have to find the value of this. We have to replace x with what? 1 and then what? Minus 1. But what? Nothing else. Okay, so to find the value of this, let's here we're gonna put this one is equal to 1, and then here we're gonna put this one is also equal to what? 1. So first, remember, always when you are finding the value of a definite integral, it is what? The upper limit minus what? The lower limit, or the upper bound minus what? The lower bound. So yeah, as I told you earlier, I should have bring about maybe 2 vertical lines here, one here, that I indicate what? The limit, one on top, one on down, but I didn't do it. You sorry for that. Next time I'll try and then do that one for you guys. But that one is not a public, that one just to tell us we are done with the integration, and the answer that we have gotten is to be what? The answer that we have gotten, we are to find the value of that particular expression that we have gotten as our answer. So we are just going to find the value of what this expression. So let's first put 1 into the whole of this expression, and then later we subtract the other one, that is minus 1 also from it. Upper bound minus lower bound. Now when you put 1 into there, you're going to get sine inverse of 1 minus square root of 1. Now 1 squared will give us what? 1. Already is minus, and then 1 is positive, so 1 squared minus 1 give us what? 1. Now 1 squared minus 1 give us 1 minus 1 will give us what? 0. Square root of 0 is what? 0. Sine inverse of 90 degrees will give us, sine inverse of 1 will give us what? Sine 90 is equal to 1, right? Good. Sine inverse of 1 will give us what? 90 degrees. So this one will give us 90 degrees. Now let's come here. Sine inverse of this one will give us what? Minus 90 degrees. Minus 1. 1 minus, s is what? Minus 1. So minus 1 squared will give us positive 1. So 1 minus 1 will give us what? 0. 0 square root of 0 is what? 0. So you're going to get what? Minus 90 degrees. So here, this one will just give us 0, and this one will be 90 degrees, and this one will also be minus 90 degrees. Then we open the bracket. When you do so, you're going to get 90 plus what? 90. Now 90 plus 90 will give us what? 180. Now, this one here is the value of the particular question in degrees form. But we can leave our answer like this. When we do so, we are not wrong, but the question has what? Restricted us that particular question that we are to give a proof of is equal to pi, but not what? 180 degrees. The question didn't say that the integral question was equal to what? 180 degrees. So, but rather is equal to pi. So to get the value in terms of pi, we have to change this one to what? Radian. This is the value in degrees, but what is the value in what? Radian. Because it was stated in radian. 180 is never equal to pi, but rather when you change this one to radian, you will know the value what of this one in what? Radian. Okay, so we're going to convert 180 degrees into what? Radian. Okay, so let's convert, and this conversion, the formula that I'm going to use is what you are used to convert the 90 degrees to what? Radian. Okay, so the formula is pi over 180 times what? The degrees. Pi over 180 times the degrees. Let's assume this one is not there. It's pi over 180 times what? Degrees. Okay, the degrees is representing what? The particular what? Angle. Maybe 90 degrees, 45. Now, when you put 90 here, 90 can go into 180 how many times? 2. That is why 90 degrees in radian is what? Pi over 2. Now here we are converting what? Pi 180 to what? Radian. Now here, pi over 180 times what? 180. What are you going to get? This and this will go off. What are you going to get at the end of the day? That is what? Pi. So you see, both in the theta word and the x word has given us what? The same answer. So either you decide not to change the limit of the integral, but later to go back to the x word, you're going to get the same answer, or to do everything in the other word, you are still going to get the same answer. If you do everything in the other word and the answer that you get is different from when you return and compute the when you return to find the value in your original word, and they are not the same, it means you are wrong. At the end of the day, both worlds, maybe either you or x or maybe blah blah blah, has to give you the same answer. Okay, so guys, at the end of the day, the integral that we were supposed to give a proof of is successfully done, and we have realized that particular integral is actually equal to pi, because the workings is the reference what shows that that value of that integral is what, that definite integral is what, pi. So therefore integral with limit going from -1 to +1 square root of this over this is equal to pi, is equal to pi. So that's it, guys. I believe you like this video. So if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.